Welcome from Gothenburg, Nebraska. My name is Brett Lynn, a trainee at the Bear Water Utilization Learning Center. This is the fourth video in a series commemorating the 350th anniversary of the discovery of phosphorus. In the third video, we explored the 4R Nutrient Stewardship framework, established our goals with respect to phosphorus in our cropping system, and discussed our overarching phosphorus management strategy. In this video, we'll get into the right source component of the 4R Nutrient Stewardship framework. To recap, the 4 R's are the right source at the right rate, at the right time, in the right place, which balance the demands of the environmental, social, and economic aspects of the cropping system. Before we can dive into the various fertilizer sources, I want to review what a fertilizer label is and how to properly read it so we know the true composition of our fertilizer source. In a previous video, we mentioned the 3 primary macronutrients, which are nitrogen, phosphorus, and potassium. We can see the grade statement on our label, and those are reflected in the grade statement as a % weight. However, it's important to note that nitrogen is the only one that is truly reflected as nitrogen. The second number, while representing phosphorus, is actually % P2O5, and the third number represents potassium. However, it is actually % K2O. This is a guaranteed analysis, so it is a number we can take to the bank when calculating fertilizer application rates. Briefly, we will cover some common phosphorus fertilizers broken into 2 categories, dry and liquid. In the dry category, we have monoammonium phosphate, or 1152O. Again, by weight, 52% of that product is P2O5. Our second dry source is diammonium phosphate, or 1846O. Lastly, while not prevalent in row crop production, is triple superphosphate, or O46O. As you can see, this is our only phosphorus source listed that is pure phosphorus and is not accompanied by nitrogen. In the liquid category, we have ammonium polyphosphate, or 1034O. So what are some common things we need to consider when selecting a fertilizer source? Well, first off, dry versus liquid, we need to think about what our application opportunities are, how we're going to apply that source. Additionally, we need to think about our soil conditions. A research group in Australia found that in calcareous soils, liquid phosphorus actually performed better than a dry phosphorus source because not as much calcium precipitated with the phosphorus. Additionally, we need to consider placement. Where is the phosphorus going in our cropping system? We noted that many of our phosphorus sources are also accompanied by nitrogen. If we're placing that source in furrow, we need to think about our salt content, or the total N going in furrow, so we do not injure the seedling. Lastly, we need to account for value of other nutrients. At first, it may seem overwhelming to compare the price of phosphorus per unit from 2 different phosphorus fertilizers. However, we're going to cover a simple calculation that will enable us to do just that. First, we need to know what our primary nitrogen source for our cropping system is. In this hypothetical example, we have selected urea at $361 per ton. That equates to 39 cents per pound of nitrogen. Next, we must adjust the price of monoammonium phosphate at $460 a ton for the value of nitrogen. We must determine how much nitrogen is in a ton of monoammonium phosphate and equate it to the total value. We must then deduct that from the $460 per ton of MAP, which gives us an adjusted value of $374.20. From there, we are able to take the $374.20 and divide it by the total pounds of P2O5 per ton to arrive at 36 cents per pound of P2O5. Likewise, the same process applies to diammonium phosphate at $436 per ton. We need to calculate the total pounds of nitrogen per ton of diammonium phosphate and account for the value of nitrogen at $140.40 per ton of diammonium phosphate. We deduct the $140.40 from $436 to arrive at an adjusted price of $295.60 per ton of diammonium phosphate. We then take the adjusted value and divide that by the total pounds of P2O5 per ton of diammonium phosphate, which is 32 cents per pound of P2O5. We can now see that there is a 4 cents disparity between monoammonium phosphate and diammonium phosphate per pound, which can add up greatly over our total acres. I'd like to thank you for your time, and I look forward to discussing the right rate component of the 4R nutrient stewardship framework in the next video.